So let's try another example of recursion, which is a little bit richer than Fibonacci. All right, so to talk about this, what I want to do is create a text file, and we'll call it combination notes.txt. All right, so this is a combination example. Switching to typing versus writing, because I feel like this is kind of a typey example. Okay, so let's say we're given 4 people, and we'll label those people A, B, C, and D. All right, and our goal is how many 3 people committees can we form? All right, so that means 3 people committees. So for an example, we'll just do our solution. We'll start the solution, but then you should try this on your own. So A, B, C, that's one 3-person committee. All right, so can you form other 3 people committees given that solution, partial solution? So see if you can do that. Like hit pause and try it. Okay, so I'm assuming hit pause, you made a good effort. So I've got ABC, ABD, ACD, and BCD. Now, if you came up with other committees that were just scrambling the letters but not introducing any new combinations where order doesn't matter, then what you were doing is you were permuting the committees. But really, it doesn't really matter if we have ABC or BAC or CBA. It's all the same committee. It's still the same 3 people on the committee. So since order doesn't matter, this is a combination. If order mattered, it would be a permutation. All right, so there's a way of expressing this. We'll call it combo 4, 3 equals 4. And what we're going to say is this is given, so how do I want to say this? So this is given n objects, choose 3, or choose k at a time. All right, so here n equals 4 and k equals 3 in this example. All right, in fact, I think I'm going to move this and say this is an example. There. All right. And we'll change this to combo of k, n, choose k. All right. So given 4 people, A, B, C, D, we want to choose 3 people at a time. And so the solution is that's the list of different combinations, but we're interested in what is the total number, right? How many people, 3 people committees can we form? So this is how we go about just looking at the possible combinations of 3 people committees, but ultimately we're just interested in the count. What is the number? Okay, so let's try another one. Given 4 people, A, B, C, D, goal, how many 2 people committees can we form? What do you think? Do you think it'll be more or less than 3 people committees? All right, so the solution, well, why don't you try a solution? Remember, I'll give you the first one. So the first one could be AB. All right, so give it a shot, see if you can come up with your list and hit pause. Now I'm assuming you've come up with your solution. I'm going to come up with mine. So I'm just going to work with A's first. So I can have AB, AC, and AD. I can also have BC and BD, and I can also have CD. So the solution is there are 6. And we can express that by saying combination of a population of 4 or 4 people, choose 2 at a time, that's going to be equal to 6. All right, let's do one more. Given, I'm just going to copy and paste this, 4 people, A, B, C, D. And the question I have is, how many 0 people committees can we form? Now, why do you think I'm asking for 0? It seems like an odd thing, and also the answer is pretty obvious. Since what we're talking about here is recursion, hopefully what we're going to be able to do is we're going to be able to find some way of recursively expressing this combo method. And if we can get that expressed recursively, we also need to have base cases. And so we're just kind of exploring different ranges of k for some value of n. In this case, we've set n equal to 4. So we looked at the number of 3 people committees, 2 people committees. Now we're looking at the number of 0 people committees. All right. So given 4 people, A, B, C, D, how many 0 people committees can we form? The solution is 1. There's 1 0 people committee that doesn't contain A, B, C, D. All right. Cool. Now, one of the problems with this approach, I think intuitively the approach makes sense, but one of the problems with the approach is it doesn't scale really well. So I'll give you an example. So I'm basically saying enumerating committees by hand doesn't scale. And here's why. Combo of 36 people in my committee, but I'm only interested in looking at, I want to form, or 36 people total, and I want to form committees of size 6. How many of those? Well, that's equal to 1,947,792. So that is not something you would want to enumerate by hand. You might spend the entire semester just doing that. All right, so can we create a recursive solution? Of course we can. Of course we can. All right, so what is the recursive solution to this? Well, let's take a look. So here is another example. Given 5 people, A, B, C, D, E, and our goal is how many 3 people committees can we form? All right, so one way of solving this is the following. Step number 1, find the number we'll do this. 1. Find the number of 3-person committees without E. All right, so I'm going to list those. ABC, ABD, ACD, and BCD. This should look pretty familiar because this is essentially a combo of 4, choose 3. And we just did that. We worked that out right up here. That was our first example. We had if we remove E, we're basically back to this original example. Given 4 people, A, B, C, D, how many 3-people committees can we form? That's 4. And we can express that as combo 4, 3 equals 4. All right. Now, we're not done yet because we haven't worked with E yet. So step 2, we're going to find the number of 2-person committees and then add E. So the number of 2-person committees, if we have combo of 4, choose 2. So we're finding the number of 2-person committees without E. Without E. And then we're going to add E. So the combo of 4, choose 2, we already know that. That's going to be equal to 6. And how do we know that? Well, let's just list the 2-person committees. It's AB, AC, AD, BC, BD, and CD. Now all we're going to do is just add E to each one of these. So E, 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 E. Whoops. The fact that we're adding E to each one of those doesn't change the fact that we have 6 of them if we're looking for the number of 2-person committees without E. All right, so we have the combo of 4, 2. So what does this mean? Well, what we actually just did is we expressed the combo of 5, choose 3 as the combo of 4, choose 3 plus the combo of 4, choose 2. That's what we just did, right? We were looking for how many given 5 people, how many 3-people committees can we form? We said, okay, let's just break this into a couple of problems. First, find the number of 3-person committees without E. That's totally legit, right? You can certainly form some of the 3-people committees just using A, B, C, and D. And then we said, okay, now if we want to account for E, let's just find the number of 2-people committees without E using A, B, C, and D. And then just tack E to the end of that. That will actually give us the full list of 3-people committees given 5 people, A, B, C, D, and E. So because that's legitimate, let me just move this up here. Because that's legitimate, what that means is we can express the combination of 5 people choose community size of 3. We can express that combination as 4 choose 3 plus 4 choose 2. So this is a specific example, but we can now generalize it. We can say, given n people, goal, how many k-person committees can we form? All right, so we're going from the specific, we did a specific example, to the general. And so our solution is combo of n choose k is equal to, well, let's see, we were doing 5 choose 3, so we said it was the combo of 4 or n minus 1 choose k plus the combo of n minus 1, sorry, that's 4. So n minus 1 choose k minus 2. All right. I'm sorry, k minus 1. n minus 1 choose k minus 1. Okay. So we took this specific example and then generalized it and said, look, if you want 5 choose 3, that's the same thing as saying if you want n choose some committee k of size k, it's equal to the combo of 5 minus 1, which is n minus 1, 3, which is k, and we're going to add to that the combination of n minus 1, which is 5 minus 1, which is 4, n minus 1, and then k minus 1, 2 is k minus 1, and that's our recursive solution. Now, that is the recursive expression, all right? So no matter what combination call you provide, we're going to have this expression. But we also have to deal with base cases. We have to do something that stops the recursion. So this is the recursive case. So I might just say, yeah, bring that in here. So we've got the recursive case. What about our base case? Is there a specific combination of, or is there a specific value of n or k that could stop the recursion? I don't actually think we want a specific value of n. That could get us in trouble. I'm not sure how we would generalize that. But we just did do one example up here where if k is 0, and I might want to express that here. So the combo of 4 choose 0 is equal to 1. How many 0 people committees can we form if we have 4 people? So if n is 4 and k is 0, we get 1. And that would be true no matter what value of n we had, right? If n is 5 and we're asking how many 0 people committees can we have if we have 5 people, it's always going to be 1. So we can generalize that down here and say that the combo of n choose 0 is equal to 1. And do we have another base case? Well, what if we did the combo of n choose 1? I'm sorry, n choose n. All right. So if k has the value of 1, if we have 5 people, how many unique 5 people committees can we form? Well, the answer is 1. Right? You can't, unless you're permuting, you can't have more than one unique 5-person committee if you have 5 people. All right, so now that we have the base cases and the recursive cases, we can write some code. So we'll call this our pseudocode. We'll just say pseudocode. Maybe we'll just do it that way. So pseudocode is it's sort of like Java, but not exactly. And you can create your own pseudocode language. This one I would call the pseudocode language of Bob. All right, so the pseudocode language for the solution is combo, well, we'll just write it. So typically I like to write the base cases first. So if n is equal to, well, it doesn't matter what the value of n is. We're really interested in k. So if k is equal to 0, or k is equal to n, then what we want to do is the following. Combo of n choose k is equal to 1, right? If you look at it, that's pretty much what we said here with the base cases, right? If you pass in combo n 0, which makes k 0, or you pass in combo n n, which makes k n, there's only one possible combination of that, all right? Else, combo of nk is equal to combo of n minus 1 k plus combo of n minus 1 k minus 1. Wow, that is awesome. That is amazing. This really is not a lot of code, right? We're taking combo nk and solving it using simpler versions of combo. And we have two base cases. When k is 0 or k is n, we can solve the problem and return the value 1. Awesome. So now what we want to do is take this and convert it into actual code. So let's do a file, new file, and create something that we're going to call combination.java. And we're going to just take the code from Fibonacci and copy that. All right. Change the name here to combination. Change this function to combination. We'll figure out what that does in a second. We'll just have it return 6, let's say, for right now. So it's a stub. And now let's look at the main program. Enter an n and k to find the number of committees of size k given population of size n. All right, and let's just close that. And we've got our scanner. We're going to read in n, and then we're going to read in k. All right. And then we'll say number of committees of size k is. And we'll call this combination n, comma, k. Fantastic. All right, so let's run it. Again, it doesn't quite work yet because we haven't put the recursive code in here, recursive solution, but let's just compile and run it just to see. Oops. Oh, it's not happy because I don't actually have my int k here. Let's try that again. There we go. Enter an n and k to find the number of committees of size k given a population of size n. Well, in our notes, we have some examples. So it might be kind of cool to put in 5, 3. Now that should be 10. The answer should be 10 because that's 4, 3 plus 4, 2, which is 6. 6 plus 4 is 10. But of course, when we run it, we're not going to get 10. Let's go to that terminal window. There we go. We'll get 6, but that we'll resolve that when we actually write the code. So the value of n is 5. The value is 3. So we of k is 3, so we're going to find, hopefully, the number of communities of size 3 given a population of size n. Okay, and it says the number of communities of size k is 6. That's because we haven't actually written the code to make it work yet, but we're about to do that. Okay. To get that code, why don't we just copy this, and we probably have to do a little bit of fiddling to make it truly Java, but probably not too much. All right, so if k is equal to 0, or we got to switch that or to that, or k is equal to n, then what we're going to do is we're going to return the value of 1. All right, else we're going to have a recursive solution. And the recursive solution, instead of saying combo nk equals, we're just going to say return combo n minus 1 comma k plus combo n minus 1 comma k minus 1. Put a semicolon there. That's really it, folks. I'm assuming we did this correctly. We came up with the recursive solution correctly. That's really it. So let's do compile and run. Oops. Just have to change that name because we called it combination. And down here, we call the combination as well. All right, compile and run it. Okay, enter n and k to find the number of committees of size k given population of size n. Whoops, so we're going to put 5 in and 3 in. So we have a population size of 5, and we're going to choose committees of size 3. And it says that the number of committees of size k is n. Cool. Why don't we try that crazy one? Let's see, we have 36 and 6. Awesome. So that worked really well too. All right, so we have a working version of our combination example. Now, I think just like we traced the Fibonacci number sequence, it might be worth trying to trace the combination example. And so let's do that. And it turns out that it's not as hard to understand or figure out as you might expect. So let's do that example. I'm going to get the code up, and we'll just do some screen mirroring. All right, so I'm going to abbreviate with C. Okay, so here we have C of, let's say we have a committee population size of 3, and we want to choose 2. All right. So this is really saying combination 3, choose 2. So we have a population of 3, and we want to figure out how many 2-person committees we can form when we have a population of 3. Well, that is going to trigger a recursive call to our program, because when you pass in 3 here and 2, k is not going to be 0 and k is not going to be n. So we're going to return a combination of n minus 1 k plus combination of n minus 1 k minus 1. So that means that we're going to have a combination of n minus 1 k, so that's a combination of 2, 2, plus a combination of n minus 1 k minus 1, 2, 1. All right. So both of these have to be resolved into actual values. So they're going to have to trigger base cases. This base case will get triggered immediately. because now n is equal to k, and when n is equal to k, or k is equal to n, we're going to return the value of 1. So this is going to return a 1. So that 1 will now be replaced here, and our expression is going to be 1 plus whatever this resolves to. All right. Well, n is not equal to k, and k is not 0, so we're going to have to break this down a little bit further and say the combination of 2 comma 1 resolves to the combination of 1 comma 1, that's n minus 1k, plus the combination of 1 comma 0, that's n minus 1, k minus 1. All right, now we have this one, this combination call, n is equal to k. They both have the value of 1. So that's going to resolve to the value of 1. And then that's going to be returned here. And we're going to have 1 plus the value of whatever this resolves to. Well, in this case, we're going to trigger our base case again because k is now 0. And so that is going to resolve to the value of 1. That's going to be returned up here. And now we're going to have 1 plus 1. Those two added together, we add these two together, we're going to get 2, and that's going to be returned up here as 2. All right. Now, that 1 plus 2 is going to give us 3. And so the value of 3 comma 2 is 3. Combination of 3 comma 2 is 3. Let's try that out just to see it running to make sure that I didn't mess anything up here. Okay. So if n is 3 and k is 2, yeah, the number of committees is of size 3. And this diagram here that I just drew shows you how those recursive calls are resolved. There's kind of an important timing here as well that you should be aware of, right? This expression gets resolved first, and then this expression gets resolved. In order for this expression to get resolved, we have to resolve this expression first, and then this expression. And then the combination of those two gets resolved and returned back to here. Now, once this and this are resolved, this expression, which now has values associated with it, gets resolved, and we get an answer to our problem. Pretty amazing.